Ba-da-da-bow! Hey, welcome to the show. It's me, JP. It's time for JP's product pick of the week. We have arrived. It's Tuesday already. Can you believe it? Wow. So, first of all, thanks for stopping by in our chats. We've got our YouTube chat up. Dave Odessa, how you doing? Tackle the World. Nice to see you. Yeah, today is not 1080p day. I'm going to try that on my Thursday show. On the workshop shows when I'm going to attempt 1080p. Did I promise this one? I don't know, but in my mind, that's when I'm going to be doing it. And hey, Beatagrafte, Avdahagen, and Quinman16. Nice to see you too over there in our YouTube chat. If you're somewhere else and you're wondering where our chat is, then you could do worse than heading over to Adafruit.it/Discord and then jump on over to our Discord server and look for the... Oh, wow, that got all resized. Hold on. I was going to say, look for the... Oh, gosh, how big do I have to... Is that the... No, let's go this way. There we go. Look for those channels on the side. Phew, that's it. I resized something. I should never resize things. Live broadcast chat channel. That one right there. That's where the chat is during live stream, so you can look over there, or you can head on over to any of our multitude of channels to talk about the things you want to talk about, such as, I don't know, FPGA stuff maybe, or new products, or tiny USB, help with projects, help with Circuit Python. But right now, during this show, hang out here. It's a nice place. So let's see, before I show you the new video for this, I'm gonna tell you, head to that URL if you want to get a jump start on the product pick of the week. That's where it lives, right there at that URL and at that QR code. This show happens inside of that page, so you will find this video being broadcast from right within there. If you like to get your entertainment while you shop, then hey, do that. I recommend it. It is going to be 50% off today, and you don't need any kind of coupon code or anything like that. You get a huge discount, but that is only during the live stream. They have been marked way down low, maximum of 10 per customer. I think we have a bunch of them stashed, at least 100 stashed. So go grab some, maybe early, but if you want to stick around and find out more, then I'm going to have Lady Ada tell us all about this week's new product pick. Take it away, Lady Ada. That's not it.
Yes. So we actually got this email like a week ago. They'd seen the video, but they were like, this is what it's used for. And I'm like, it is. So this is a captain of a first team, so it's a robotics team, and they have a board that they're required to use. And if you want to do something funky with it that isn't part of like the first ecosystem, it's very difficult. So they want to use NeoPixels because they want to light up the robot, but nobody's written a NeoPixel driving library for this chipset. But they do have access to I2C, so now they could use this to control NeoPixels, which is a very common request.
This is it.
So this is just a bunch of NeoPixels, but this is the board. So the way the board works is it also has a little helper chip on there. And let me show it on the overhead because it's not lit up, but I can show how it works.
Yeah.
Okay, so 1 second. So let's say you have a microcontroller or a board. In this case, I'm using an RP2040 which does have NeoPixel support, but maybe all the PIOs are used on your RP2040, and so you want to control some NeoPixels, or maybe you're using some exotic chip that, again, nobody's ported a NeoPixel driver for. But you still want to control NeoPixels. You need that specific timing. It's very hard to do. So this chip on here, the ATtiny 1616, will take messages from I2C over here, from the RP2040, and then convert, it'll say light up this pixel, that color, and then when it's done, it says, please show the pixels, and it will write the data out to the terminal ports. So on the back, there are 5 terminals. One thing to note, you will need separate 5-volt power. The NeoPixels need about 20 to 40 milliamps per LED, and so if you're driving in any NeoPixels, you're not going to be able to power them over this little thin wire here. You'll need a chunky power supply and chunky wires, and either connect them to this terminal block, which then goes through and powers the NeoPixels. Or you can do something like this, where you have a 5-volt power supply and you just power it directly into the red and black wires of your NeoPixel. But then the signal wires, the white and gray wires here, are signal and ground. This data will come out of this chip, and so you just have to send the I2C commands. And most chips, do support I2C fairly easily, and we've documented the commands. So if you're not using Circuit Python Blinka, or you're not using an Arduino compatible chip, we have libraries for those. But if you're using something else, you could of course port it to that platform. You can drive up to, I think, 512 pixels, but I will note, you're driving the pixels over I2C, so it's not going to be very fast. You can run this at 1 megahertz I2C, and that'll do much better. The default is 100 kilohertz on many platforms. I would bump it up to 400, 800, 1 megahertz clock rate, and you should light up as few pixels. Sorry, you should write as few pixels as possible before you show the entire strip, because every time you change a pixel color, it has to send a message back and forth to say, hey, this is what the pixel color should be. So that will slow it down, and you're never going to be as fast as native NeoPixel driving. But if you have no other way of driving NeoPixels, it does work. Basically, as you get to like 200 pixels, it can slow down a bit. But for about 100 pixels, writing the data at 800 kilohertz or 1 megahertz, you'll get almost equivalent to native NeoPixel driving speeds. So this could be a really easy way for you to add NeoPixel support to a chipset that you've got, as long as it's got I2C, 3-volt or 5-volt I2C it'll work with. And it even has a little switch cap converter here. So if you're running this off of 3 volts, it'll generate a 5-volt signal for a nice clean NeoPixel driver. And you can change the I2C address if you want with these jumpers.
That is all true. So here it is. Check it out. That right there is my product pick of the week this week. It is the NeoDriver I2C NeoPixel board. So as Lady Ada mentioned, this is really useful in a couple of pretty particular scenarios. One is you have a single board computer in particular that just can't do NeoPixel timing on any of its pins, and this isn't all that uncommon, but a lot of those will have I2C. So be able to plug from this STEMMA QT connector into the I2C and 5-volt and ground, or 3-volt and ground pins on your single board computer. Send I2C commands, NeoPixel commands over I2C, I should say. And then this has these nice header blocks here, screw terminals, that you can plug in your NeoPixel for data and power. It also has a couple of slots there where you can plug in your external power, so you can use a nice big beefy 5-volt power supply. And that way you're off and running, and you can control NeoPixels on boards that you normally can't. Another scenario is in the case of something like the in the case of the RP2040, if you have an RP2040 board and you're using the PIOs for something, those PIOs are usually used to bitbang the NeoPixels. But if you look at something like our USB host feather, that's using both PIOs already just to do USB stuff. So you basically can't do NeoPixels on that board while using the USB host capabilities, unless you add something like this, and then we have that whole I2C bus over on the side there to send the NeoPixel commands. So really convenient for a couple of those scenarios where you want to use NeoPixels, but the board just won't let you. So I want to show you a kind of cool demo here. Let me change up camera stuff a little bit. And also, I'll just take a moment and say, see, Grover noticed I had a microphone fading in and out. That may have been my microphone flopping around because the battery levels look good on my receiver and transmitter. But if it's still having a problem, please let me know, and I will try to swap out batteries on that. So let's go to this down camera, and I will refocus that big blob into a, you guessed it, single board computer and our little friend here. So this is the, let me add another camera there. There we go. So this is the Le Potato from Libre Computing. This is a single board computer in the Raspberry Pi form factor. And in fact, you can run Raspberry Pi operating system on this, which I am right now. And this can't drive NeoPixels on its own. but it's got I2C, and thanks to Liz Clark, who came up with the proper recipe for getting this to work and documented it and shared that with me, I now have the NeoDriver board plugged in over I2C to the Le Potato, and then I have power coming from a 5-volt DC supply, 4-amp supply, in fact, kind of overkill. And then I have a nice NeoPixel strip, about 60 NeoPixels, plugged into these little terminal headers here. So if we take a look at my terminal here, I have a nice little SSH session going into the Le Potato here. We could also, of course, have keyboard and mouse and HDMI plugged in, but for this demo, this is a little bit easier. And if you look what I've got here, I have a little Python script. This is using Blinka, so we can use all of the same sort of Circuit Python libraries and commands that we know and love. And what I'll do in this case is run Python 3 NeoDriver test. And what that's going to do is light up these NeoPixels. Wow, that's bright. Let me drop my exposure just a bit so you can see that a little better. There we go. That's nice and colorful. And so this has just over the NeoDriver board lit up my NeoPixel strip. Now, if we look at the code that I'm running there, so this is, boy, this looks familiar, right? Importing time, Rainbow I/O, and color wheel. I'm using the extended bus for I2C. This is a way that Liz was telling me about to use I2C on these boards with some better capabilities. Then we have the seesaw we're using. So the chip on here uses seesaw, and that allows us to use the little chip on there to drive a variety of things. You can make GPIO things with it. You can use NeoPixels with it. So that's the seesaw protocol used there. And then you can see I'm establishing I2C on I2C bus 1. There's actually 2 buses on this board in particular. I'm using bus 1. And I've set that frequency of the I2C transmission up to 800 kilohertz. Then I'm setting up a seesaw object here on the address 60. As Lamore mentioned, you can set up to 4 of these on your bus, on one bus, by changing their addresses. And then I have the NeoPixel pin on that little STEMMA board that's there, STEMMA seesaw board that's in there is on pin 15. And then I happen to have 59 NeoPixels because I cut this one sort of in half. I think it was 120 to begin with. Then I'm establishing or instantiating this NeoPixel object called Pixels, and that's being set up on Seesaw with that pin 15 with the 59 NeoPixels. I've set a brightness to 3, and then I have automatic write turned off, and that is kind of a key to making this run fast. You don't want to send write commands all the time, just when you're ready to write something. I have a color offset, which I'll use to change colors in a second, but that's in the sort of main loop that I'm not running. Right now, if I just change this, let's say to, how about, we'll go to green. So I'm setting a color 00FF00. I'm going to save this, and then I will run the script again. And this time when it runs, boom, we've got some green NeoPixels all running on a board that can't do NeoPixels, which is pretty great. And I'll go and do one last little change here, which is I'm going to uncomment this main loop here, which is going to run through and update every pixel in the color I/O or color wheel, Rainbow I/O color wheel, sort of in a row. So we're going to get a rainbow swirl, pretty typical rainbow swirl. So I'm going to save that and rerun it. And here you go. This is not slow. At first I thought, uh-oh, this is, with all these warnings, is this going to be disappointingly slow and we're going to be sad? But no, I'm here on a little single board computer that can't on its own do NeoPixels, and yet with our little NeoDriver we are doing some very respectable NeoPixel driving, which is really terrific. So this is the demo of this. I'm going to step away from this for a second, and let's head over to the main page here. So you can see these are on sale right now for $3.75. So they are half off. I'm distracted by the chat where Beata said that they heard rainbow squirrel. It's a, I wish, that's not as exciting. I have a rainbow swirl, but a squirrel, that'd be kind of cool. So here we have the main page in the store. If you want to get some of these, throw them in your cart. There's no coupon code needed. Those are half off just during the show, so that price will go back up after the show. You might also want to pick up some of these little STEMMA cables. So this is the STEMMA to header, female header pins. That's great for plugging into that set of header pins that are on your typical small single board computers. But you can, if you're using something like a QT Py, then you can just get a typical STEMMA QT to STEMMA QT type of cable. If you scroll down in here, you will see there is a link to the main guide. So I'll head over there. I have that loaded up already. So here's the main guide. It takes you on a little tour of the board. You can see there we have all of those nice headers for screwing in your wiring. Stranded wiring is really nice with these in particular. I wouldn't use solid core. Those tend to pop out. You can plug in STEMMA QT on either side of that. You can also chain through it on the I2C bus if you're using multiples of these or other boards, other sensors, inputs, and so on. So it's your typical I2C STEMMA QT party there. And then if we take a look at the pinouts here, you can see some details on that. There's a nice photo of the backside there where you have your jumpers that you can slice to change the I2C addresses. Talks about your power and logic pins. There's a little info about which addresses you'll get. You can also get a, I'm going to actually jump back over to my demo for a second since we're talking about addresses. I'm going to stop this code for a second here. If I run a little bash script that I wrote called what? Overlay. What you'll see is this is a sort of a Raspberry Pi or single board computer or Linux thing here where we can enable that extended I2C bus and do a little search of what's on the bus. So there's something on bus 0 called at address 30. I don't even know what that is. That must be something that's just built onto here. I think there's like an I2 or like a IR receiver. Maybe that's over I2C. I don't really know. If someone knows, let me know. But here you can see in this second statement here, we get the little graph of addresses, and you can see we have address 60. That's the default for this. And if you want to look at that little overlay, you can see I'm doing this LDTO enable I2C AO. This is all the magic that Liz came up with to make this work. And then I'm listing the possible I2C buses. Then this doesn't make sense, but I'm just, whether they're there or not, I'm running detect, which is why you can see one of those fails. But this is how we do the I2C detect. You can normally run these from the terminal one by one or command line one by one. I just wanted to be able to do all of this because unfortunately right now, at least on this computer, you have to rerun these when you boot the computer. So you might work this into a boot up script if you were always using this and this was permanently set up. But again, thanks to Liz for figuring all that out. And back to the guide here, you can take a look at some examples you can do in CircuitPython and Python. So this will show you some wiring suggestions for how to wire things up either directly with cables or using a breadboard in the middle, how to set that up on a single board computer, and then some examples of the setup that you would do to install the necessary libraries and get that up and running, as well as some example code. So you can go check that guide out. You can also take a look at on Liz's own user page. So if you click on Blitz City DIY anywhere, you'll get to this, the user pages, and this one is the specific instructions for getting this to work with Le Potato, which was one of these single board computers. Kind of a cool board. I'd never heard of it before, and I like it. I think, especially because this one runs Raspbian OS, it's a really good, if you've been searching and searching for a Raspberry Pi, I know they're coming back into stock much more every day right now, and soon they should be back to normal. But if you were in need, there's a chance this would actually do what you needed to do, and it's the same form factor, so it'll fit most of the cases and peripherals and hats and things you can plug in. I say that just because that's what they're advertised as. I haven't tried anything on this outside of this right here and plugging it into a monitor with mouse and keyboard to get it up and running initially. But kind of cool computer, and I think it's like $35 for this, maybe $45, something like that, so not bad. So let's see. Let me see if we've got any questions right now. And actually, while we chat, I'm going to run my swirly animation, not squirrel animation. Get that. Ooh, look at that. Back up and running. You know why this looks good? Because the NeoPixels are not pointed at the camera. Pointing them, this is side-lit NeoPixels, but pointing them down at my desk here, especially if I lift it off the desk a little, these are a lot better to look at indirectly than directly. The camera doesn't like them directly. So Rufus asks, does I2C just transmit pixel number and values? In other words, are there global commands like all off, all brighter, shift pixels right, etc. to save bandwidth? There are, yeah. So some of the stuff I was doing when I just had single colors, the code for that is setting all the pixels to a particular color and then saying show pixel, so that's transmitted as a single command over I2C. Then that's sorted out on the chip there, which is what's actually running the NeoPixel code. And if not, is it possible to program the ATtiny1616 on board to add commands? I would think so, but I haven't tried that. If anyone has expertise in that or knows, that would be great. Would that make it incompatible with the Adafruit library? I think so, yeah. You could fork the library and add code to it if you wanted to, I think. But currently you use pretty standard NeoPixel commands. Those head over I2C, and then they're, those are sent, those individual pixel messages are sent right off of the ATtiny built onto the board there. Let's see, any other questions? What exact OS version are you running on Le Potato? I am running, Liz, do you remember? It's a Raspbian OS. Actually, I think it's on that page that she, well, there's some links there. So download Raspbian image for the SML S905X from the distro server. If you look here, I grabbed, where are you? This one. Actually, I think it's AML. That might have been a typo. So this is a 2022 922 Raspbian Bullseye ARM64 AML S905X-CC. So it's a little bit old. I don't know if there are newer ones, but that's the Raspbian build that I was using that was suggested by Liz. And I think that's probably just on the, yeah, that's the distro server from Libre there. And they've got an Ubuntu on there as well. Yes, yeah, so that may be the latest one. I don't know if there's others out there. I just, like I said, I don't know a heck of a lot about it right now. All right, other questions? Laris says the NeoDriver board's really nice, expecting something like this appearing for multiple years. Yeah, and you know what, I'll tell you, here's another scenario where I think this could be useful. I did a hack with a little fader, kind of MIDI fader board that Tom Whitwell's Music Thing Modular put out called the 8MU. That has faders, it has USB, it has a plug on it for MIDI, and I think it may have a STEMMA QT. Another one's the macro pad, that one I'm sure of. So our macro pad has pins available, but they're not broken out anywhere because it's kind of like an all-in-one device. But it does have a STEMMA QT port. So if you wanted external NeoPixels running from your macro pad, that would probably be the best way to do it. We also have some things like some of our more handheld types of things, Matrix portals, or Pi portals rather, Pi Gamer, Pi Badge. A lot of those they have feather outs, but this would be a much neater solution rather than plugging feather pins in, is just plugging into the STEMMA QT. So pretty cool, and that would run just fine in CircuitPython, and I think Arduino as well over I2C. Let's see, any other questions we've got? Yes, Paul Ramasco asked what SBC is that? It is Le Potato. It is a Le Potato. I love that. Why don't they just call it pomme? Isn't that potato in French? I guess that's not anywhere near as fun. Terrific. So I think that's going to do it. I will wrap up here. I'll just remind you again, if you want to go and grab one or some of these, that is your QR code. That is your URL. It's product 5766. Head on over there and grab some for yourself and use your NeoPixels where you didn't think you could use them before. All right, let's wrap this up. That's going to do it for today. My product pick of the week this week is the NeoDriver. It is an I2C STEMMA QT NeoPixel board. That's going to do it. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. I will see you soon. Bye-bye.